Greetings, this is Matt Nyman, and as promised, here is a narrated PowerPoint for SED473, 573 for week 7, our class on Thursday. This presentation will be a mixture of a impromptu type of presentation as well as some more scripted parts of the presentation where I've actually extracted some information from a couple of papers I read and have typed up some notes. So there'll be some choppiness to the presentation, but there's some also, I think, some very interesting information that will be covered. So there are two specific learning outcomes related to this presentation. The first is to have a first pass at understanding the importance of language in science, teaching and learning. And specifically, this will be focused around some of the NGSS science practices. The second learning outcome is to look at some specifics about languages and the application of languages to the EdTPA. That'll include some definitions of terms that you'll see in EdTPA. And I'll also highlight some handouts, some documents that I've gotten from the resource page that I'll also put up on the website that will be useful as you move through developing lesson plans and so forth. So the term language is used over 130 times in EdTPA, and the term discourse is a significant part of our work around ambitious science teaching. So what this adds up to is that having some knowledge about language and being mindful about how language works in your teaching or doesn't work in your teaching is important for being successful, for your students being successful in learning not only the content but becoming comfortable with thinking and talking about science. This slide shows some of the language-specific aspects of EdTPA, which I'll cover later on in this presentation. These are some of the terms that come out of both the rubrics as well as some of the background information. And I'll be talking specifically about these a little later in this presentation. And when we're talking about discourse, of course, we've been covering this a lot in our work with ambitious science teaching. Discourse around specific scientific phenomena that occur in the real world, the natural world, is one of the foundations of ambitious science teaching and one of the foundations of being able to find out what your students are learning around science. So the main point behind this set of slides is that language is an important component of your teaching and of your students' learning, and is embodied with both the way that we're evaluating your growth as teachers with EdTPA as well as the application of this ambitious science teaching framework. Now, there is also a bigger framework that's at play here in terms of English language learning, and this is centered in part around excuse me, in part around English language proficiency standards that have been put out over the last couple of years, and they're kind of geared towards providing guidelines for English language learners, but they're also really important for any student learning. I am not an expert at these or by any stretch of the imagination or well read in linguistics, which is required to fully digest these, but there are some standards and some guidelines that I think are worth looking at. So this is a chart that shows the 10 different content area practices that are related to language learning. And these are specific to content areas rather than just straightforward guidelines for language development. In other words, you can apply these language practices to any content area they're teaching. So I would suggest going back and looking at these. I'll put the handout online so that you can see them. But we can separate these 10 practices into a couple categories. The first category involves the first 3 practices, and these practices are all about extracting meaning about the content area. So it's looking at literary and informational text, it's participating in exchanges of information, and it's looking at how we speak and write about the complex literary and informational text. So in these 3 practices, it's all about finding meaning within the content area. Practices 4 through 7 are all about engagement in the practices. So in this case, students are actually doing something. They're constructing oral and written claims. They're conducting research. They're analyzing, or they're adapting choices, language choices for certain tasks. So notice that in these 4 language practices, students are actually doing something, and you can see that some of these are obviously very parallel to what we do in science, like analyzing and critiquing arguments. Now, the final 3 practices are what they call micro-level linguistic practices because they're not foundational, but they are completed in service of other practices. In other words, these are things that students do or show or complete in order to be engaged with practice or extracting meaning. So what's important here is the beginning understanding that an important aspect of your teaching and your students' achievement and learning is all around several aspects of language, including simple things like developing facility with vocabulary to more complex things like developing discourse techniques to talk and share information about scientific phenomena. So that's the big idea around looking at these linguistic type of aspects of education. This is the last diagram I'll show you with respect to this literacy principles, and this was developed by a group out of Stanford, and I find it very interesting, and I hope you will too. And what this shows is the 3 kind of broad areas in education: math, science, and English language arts. And what this diagram shows is the commonality across these different fields and the practices that are involved. For instance, here are the 8 science practices out of the NGSS. Here are math practices and English language practices out of Common Core, and what they've shown is that there's a lot of overlap between these. And so, for instance, where all 3 of them overlap include engaging in argument from evidence, constructing arguments in math and literary studies, and also supporting analysis of a range of grade level complex text. So these are all part of engaging in argument, have similarities in all 3 fields. We'll look at some of these in more detail in a second in terms of the overlap between language-related functions and science practices. The takeaway message from this is that this focus on language and language proficiency goes across content areas. Our next stage in talking about language as related to science teaching is to specifically look at science practices as language learning opportunities. And I want to provide a framework to kind of discuss this concept. After that, we'll move into some specifics around EdTPA. So this model, if you will, provides one way to look at what we've been thinking about and how it pertains to language. In talking about ambitious science teaching, one of the foci for this effort is to making student ideas and thinking very visible. And anchoring events is the start of that process, because we're giving students an opportunity to examine a scientific phenomena and to use that to anchor their learning. Now, a big part of ambitious science teaching is engaging in discourse. Once again, this is a way of making students' thinking visible. And this engaging in discourse is part of core practice 2, or 2, 3, and 4. And part of practice 3 is around science practices. Okay, so, and in order to understand if the science practices are working towards getting student understanding, we have to have them make their ideas and thinking visible. Now, all 3 of these parts of this very simple model are all hinged to the importance of language, of hearing what students thinking about their science and or reading about it or looking at their models. It's all around language. So we're going to focus on science practices, and the goal of this part of the presentation, some of it which I'm going to be reading from some text that I wrote, is to exemplify that NGSS science practices are really language learning processes. So we are trying to make specific links between this importance of language and the doing of science. So I'm just going to read a little bit here of things I wrote. Okay, so NGSS has defined inquiry around 8 science practices. These are what scientists do to understand the natural world, and these are required for science learning. There is a mutual support between science practices and language. That is, using practices requires specific academic language components, and growth in academic language allows growth in the 8 science practices. Therefore, teachers need the skills, knowledge, and experience and awareness of the importance of language to support science learning. So let's look at how the science practices can be viewed through the lens of language and language learning. The focus in our framework is around sense making. How can we position students to make sense of natural phenomena? What models will they develop? What data should they collect? How should they talk about the data? What activities lead to the collection of this data? To do sense making, we engaged in discourse, that is, writing, talking, and representing data through the science practices. We're going to focus on 4 of the practices that are specifically tied to language use. The first is developing and using models. Now, what are some of the connections between developing and using models and language? First, models are diagrammatic representations of ideas and concepts. Second, models may contain graphs, labels, explanatory text, which are all components of language. Third, models provide a means to use and learn vocabulary in a meaningful context. And finally, models provide a foci for meaningful discourse and sense-making of natural phenomena. Finally, the sequence of model development from observation, which is something everyone can do, to developing a model, possibly using visual or native languages, which is especially important for English language learners, to using language about the system, a learning experience, provides a powerful scaffold for students to learn science. In this practice, models are support for language development. So let me review those sequences again. So modeling involves this following sequence. You make observations, which is something everybody can do. The second step is you develop that model. Now this is a language process. And finally, you use language about the system in discourse while discussing it with students. So that's why modeling supports language development. The second NGSS science practice that's directly related to language development is developing explanations for science and designing solutions for engineering. So I'm reading again. A second practice that has strong language connections is developing solutions. In this practice, students are encouraged or required to make very explicit and clear explanation, that is sense-making, of how or why something happens. Required accuracy and explicitness is not common in everyday experience, and many students struggle with this practice. Language development around developing explanations is assisted by using diagrams, like models, lists, charts, and observations. Engaging in argument from evidence. Argument is a discourse practice, either verbal or visual. A teaching and learning focus in this practice is identifying data and observations and coordinating these with other experiences to make a supported argument. A support for this practice in language development is the claims evidence reasoning framework that we've talked about in class. Obtaining, evaluating, and communicating information, another NGSS science practice. This practice includes reading, writing, and speaking about scientific phenomena in the process of sense-making and testing models. There are special challenges related to scientific reading. Without strong reading skills, some of the sentence conventions may be difficult, and science texts are typically complex and dense. This requires teacher support, scaffolds, and strategies to enhance reading comprehensions, including using as many examples of writing and speaking expectations so students know what they need to do, opportunities for rethinking ideas in journals, and finally, rewriting formal reports in order to give students experience in developing some of these skills. Therefore, the supports for this practice are providing clear examples of expectations and scaffolding these expectations by increasing the complexity, length, and details over time. In the next section, I'm going to talk a little bit about some of the features of science text and talk that make it difficult for students to make sense of science and science phenomena. This information comes directly from an article which I'll include in this week's resources. I encourage you to have a look at this. It's not required reading, but if you need further information related to this presentation or this part of the presentation, you can have a look at that. So, science vocabulary is difficult for many students, especially those who may have limited proficiency in English. Here are some specific difficulties with science vocabulary. Some scientific terms have common use in addition to scientific use. For instance, the word theory, force, energy, folds, faults, and space. In scientific text and discourse, these have very specific meanings, whereas in common language, they are much more general. Some words are challenging, especially ones that involve some scientific activity, like to infer or compare or analyze. These are not used in common speech and therefore may be difficult for students to use at first and require specific scaffolding. There are also a host of brand new scientific vocabulary which may be new to students, words such as gene, proton, syncline, etc. These vocabulary, when not used in context, may be very confusing for some students. And finally, everyday words may have subtle shifts. For instance, why did this happen? Could be referring to a motivational behind an event, but in science tends to be focused on the mechanisms responsible for a phenomena or process. Talking science is very different than common conversation. Participating in science discourse is a socialization process that includes specific ways of talking, writing, and participating in knowledge development. This includes a different register, how people are actually carrying on conversations, as well as an attention to precision and detail during conversations. The use of multiple modes of representation is a powerful teaching strategy to enhance language growth and hence learning. This includes mathematical and visual representations, pictures, graphs, visualizations, maps, equations, etc. The difficulty is that sometimes these non-linguistic representations are not well coordinated with either verbal or written discourse. So therefore, teachers must be very specific and very guided in the way they use these multiple modes of representation to really utilize them to their fullest extent. And finally, we all know that science textbooks can be really difficult to read. The specific difficulties have been investigated by linguistic research using different tools and perspectives. For example, looking at sentence and discourse structure and language use. A very preliminary summary of some of these difficulties includes the following. The language that students see in science textbooks is different from reading students commonly encounter, for instance, in their other content courses like history or English. There are instances, as pointed out before, where students have to connect cross-representations, for instance, from graphs to text or from text to different types of models. And finally, there is a need to connect textbook reading to classroom activities and learning experience that can be difficult to negotiate. For example, sometimes textbook reading does not really connect well with what's going on in the class in terms of scientific activities. The article by Quinn et al. Also suggests a variety of strategies for supporting language learning in science classroom. And I'm not going to go through these in any detail except to list them, and you can find various specific examples within the reading that's on the website, on the Canvas site, as well as some of these are pretty general and well known. So here's a list of strategies. The first is activating previous learning. We've talked about this importance of bringing out students' understandings prior to teaching them. This can help language learning processes. Using explicit discussion of reading strategies can also be an assistance. That is, providing ways students can take notes related to their reading. Teachers can also encourage use of academic language functions like describe, predict, explain, etc. in written assignments, and scaffold these, as well as provide students to redo assignments that may not address these sufficiently. Teachers can require scientific writing as part of their courses. They can use graphic organizers such as concept maps and Venn diagrams to help students understand vocabulary and other concepts. Teachers can provide general readings with scientific themes from outside of textbooks. Journals are also a good way to scaffold and to support language learning, specifically using writing prompts that students can use. These are the sentence frames we've talked about. Teachers can also provide practice decoding scientific text, especially those connected with visual as information. This can be done in small groups as well as whole groups with a variety of guided nature to these efforts. Teachers can also provide multiple examples of desired products. They can use student journals for investigations and reflections on learnings. As we've talked about a lot in class, teachers can use a variety of discourse strategies for classroom discussions, including longer wait times, revoicing student answers, multiple enunciations of concepts using different students or perspectives, multiple modes of representation, and accepting and amplifying answers in more native language. Teachers can also develop an environment that requires students to work and talk together. For English language learners, teachers can look for common scientific words across languages. They may also find word roots that are similar. Teachers can also use ideas around funds of knowledge to facilitate learning for all students. And finally, teachers can understand the variation in communication norms for different cultures. For instance, in some cultures, crosstalk is more acceptable in some languages, whereas considered rude in others. The next part of this presentation is around SED473 and its connection to language. This is especially important because it's part of your SED473, the part that you'll be passing in as an evaluation of your emerging ability as a teacher. And there's a distinct focus on language, and some of these terms are probably unfamiliar to most people. The list up on the slide: academic language, language demands, language functions, language supports, vocabulary, discourse, and syntax are the specific areas or vocabulary that are included within the SED473 that we need to understand in order to complete this task. And in this part of the presentation, I'll be covering some of these terms and talking about how they apply to our current work. And I'm also putting on the Canvas site a couple of resources that came from the SED473 resource page that I think will help you develop your work around this part of the evaluation. So let's get started. So academic language is, well, academic language. It's the specific vocabulary, discourse, structures that are used within a discipline that may in some cases be different than more common language, but also may have similarities between things like vocabulary especially. But this is the focus of SED473, is looking at academic language. Now, language demand is how languages are used to participate in learning, and how we can use language to demonstrate that students have understood a concept, a process, or a science practice. And finally, language supports, at least finally for this part of the presentation, language supports are things that teachers do to help students better negotiate or learn about how language applies to their scientific learning efforts. Now, within the SED473, there are 4 items that students are asked to focus on: language functions, vocabulary, discourse, and syntax. And I have some notes that I've taken from the reading that's on the web page on the Canvas site, and I'm just going to go through each one of these 4 parts of SED473 in a very general way, and then I'm going to refer you to these 2 resource sheets that I'll put on the Canvas site that I hope will fill out your understanding of these different concepts. So let's start off with language functions. So language functions are active verbs that are used in learning objectives. And one way to think about this is that language functions are found within the performance expectations in the NGSS, where it is specific that students will be doing something in order to understand a concept. Now, language functions' purpose are that they are the language which is used to communicate about a certain event or phenomena. So, for instance, the word analyze is a language function, and it's used in the context of students will analyze something to understand a specific phenomena. So the word analyze is the language function. Vocabulary is pretty straightforward, I think. Vocabulary is very discipline specific, and these are terms that students need to understand in order to have discourse around a scientific phenomena. So there are 3 levels or 3 different types of vocabulary that are outlined. The first is subject-specific vocabulary, things like proton, electron, gene, momentum. No, not momentum, because momentum has a common word. In geology, fault. Though I guess it could be momentum. Yeah, momentum will work. So these are very specific to the subject. And then there's the academic terms, academic language, things like the word analyze, which have a very specific meaning when it comes to scientific work. And then there are discipline specific, which are similar to the subject specific vocabulary, that is around a specific phenomena within a discipline. Discourse is the science talking or writing that goes around between students and with teachers, where they're trying to share information about a certain phenomena, where they're representing information. So if we look at a specific example, okay, let's think about starting off with a function, a language function. So if we have a language function that is draw conclusion, okay, so that's something that students need to do around language. Now, as part of this function, you engage in discourse with students, or they engage in discourse with each other, and that may be focused around a chart or graph or some model or data. Okay, so the discourse is focused around a specific representation of information. Now, the written discourse could be started using some sort of sentence starter where students are instructed to write or explain their information using things like the results of the investigations are, or the reason I believe this to be true is. So providing them ways to start their discourse is one way you can scaffold them to begin to participate in discourse around a scientific event. And finally, syntax are just conventions for the organization of symbols, words, or phrases. So these can be things like sentences are a syntax, graphs, tables, mathematical equations. All these are just ways that we can organize information. And this is one of the language demands that EdTPA asks you to address. So that's the end of this presentation. It's a little longer than I thought it would be. And this is certainly just the first pass at understanding the importance of the role of language in science teaching and learning. And I did try in this presentation to bring this back to things we've been doing in class. That is ambitious science teaching and using the NGSS science practices. And then the other important part of that is how this applies to EdTPA. So the people that developed EdTPA and Sue-Ann and I are not asking you to become experts on linguistics around science, teaching, and learning. I think what you need to pull away from this presentation and from our work around language is an awareness and mindfulness of the importance of language and its different modalities like discourse, reading, and writing in terms of students learning. And I think when you do that and find strategies that you can use to help support that, it'll provide a focus in order to become a good science teacher. And become a good science teacher where you're engaging students in understanding natural phenomena and really getting to talk and write about that phenomena. So I hope this is helpful, and please have a look at the resources I put on the web page, on the Canvas page related to language.